born. And he set out to see if this hypothesis was true. And he searched all over for birth records, and he found some in his own country in Hertfordshire, England. By the way, his mother was born there, and that helped him find the records. In Amsterdam's in the Netherlands has good records like that. Mysore, India, some in China, and the real gold mine he found was in Helsinki, Finland, and I'll show you some data from that. So now here's a curve that I have to explain. This is really an important curve, and what it shows is if you look at the left-hand side of this graph, you'll see cardiac mortality and the birth weight of 5 pounds. And what this shows is babies born at the low end of the scale have a 3 to 5 times higher risk of dying of heart disease than babies born at the large end, where the heart mortality risk in England was very low. This curve came from David Barker in the Hertfordshire data, and now it's been repeated. And I put a little box in the upper right. You don't have to think you have to look at these, but I just want you to know that there are at least 5 studies, including one in the US, that have been done, which showed the exact same relationship that David Barker first showed from his English data. And what it showed was that there are babies in India that are born small on the average. And at the time, they said that India had the smallest babies in the world, and that the average term birth weight in the US was somewhere about 7.5 pounds. And you can see that no matter what country you're from or your ethnic background, we all as human beings live on this curve. What David Barker didn't know before he died in 2013 is that this curve goes right back up. And there are more recent data, and I've pointed the blue arrow just to one article which came out in 2019, just to show you that there's more and more evidence now that babies at the high end of the birth weight scale have the same risks for disease and dying of heart disease as the babies that are at the low end of the birth weight scale. So now we know this U-shaped curve is really important for understanding what we call the programming of disease, which happens before you're born. And one of the things you should know is if you don't remember anything else in this talk, if you can put that curve in your mind, you'll see that high risk for heart disease at the high end of the birth weight scale and at the low end. So now a lot of water has passed under the bridge since those discoveries were made. And now we know that a lot of diseases are associated with how we grow before we're born. These include type 2 diabetes, obesity, high blood pressure, chronic obstructive pulmonary disease, lung disease, asthma, breast cancer, and now we know 3 other cancers, cognitive function, and some others that include osteoporosis and other things that are very much related to the way we grew before we were born. And here's another example of one of Barker's data, which shows that glucose or type 2 diabetes, if you look at this is birth weight across the bottom, and the bars represent how high the risk is for having those diseases, especially type 2 diabetes. And what you see is on the left-hand bar that the risk is 8 times higher for a baby born at 5.5 pounds or less in England compared to a 9.5 pound baby, which is all the way at the bottom. We now know that this curve goes back up, but to be honest with you, we don't know the shape of the curve going back up because there haven't been enough studies, and scientists need to get on this so we understand it a little bit better. So I just want you to make sure you understand this graph. The bars represent the risk for either pre-diabetes or type 2 diabetes based on birth weight. And it shows you that there's an 8 times higher risk for small babies compared to large ones in this particular study. So that's David Barker. Now I'm going to tell you something about what's come from David Barker's data. And this is a whole new field of medicine called the developmental origins of health and disease. And because of this, we've been able to understand disease in a brand new way. First of all, I want to show you that there's so many outcomes that are associated with low birth weight And these include cardiovascular things. I'm not going to list them all, but high blood pressure and high cholesterol examples. Neurological changes with low birth weight, which include elevated appetite, psychosocial problems, and cognition. And lower is the metabolic changes are glucose regulation, poor muscle mass, insulin insensitivity, and a small pancreas. And with the cells that make the cells that are actually manufacturing insulin, the beta cells, are in low numbers in people who are born small, and they never get bigger. So I mentioned osteoporosis, and poor immune function is one we're just now learning about. So what we've determined is that there are specific stressors that cause low birth weight, and these can be in various combinations in different pregnancies. So, and they're all related to the placenta, because the placenta transmits nutrition and chemical signals from the mother to the baby. So malnutrition being the most prominent, I put it in red just so you'll see it. And it turns out that that and social stress are very powerful determinants of growth restriction in the womb. Fetal hypoxia is usually because of a poor placenta. And toxic chemicals are coming more and more on the forefront of our understanding of things that happen to us before we're born. So all four of these are stressors, and each one is an independent risk. But if you look in the middle, there are some people that have all of these, and there are many, many, especially that have malnutrition and social stress, who live in difficult circumstances. And those people have the highest risk for these diseases. So before we go on, I have to mention epigenetics. It's already been mentioned, and if you don't know much about it, I just want to say some simple things about it, and I'll explain how it works later. First of all, genes, as you probably know, are stretches of DNA that are coded that you got from your parents, and they're in our cells, and they regulate growth and development and maintain our bodily functions. Epigenetic mechanisms are those that regulate the degree to which these genes are turned off and on. And we hardly knew about this 30 years ago. Epigenetic processes are important for normal development. They occur all the time because many genes need to be turned off after they've completed their function. And you'll see that right away, because the genes that helped you develop when you're an embryo, you don't need those now, and they get permanently turned off by epigenetic mechanisms. However, there are some epigenetic mechanisms that are influenced by the environment, and those tend to be more important in determining whether people have disease risk or not. And these include nutrition, chemical exposures, and stress in particular. And this applies not only in the womb, but also to children in their early life. Epigenetic changes in early development may lead to elevated risks, and if those certain genes that we now know about are affected, then we know that risk goes up highly. The disease risk associated with poor growth in early life are mostly explained by these epigenetic changes caused by stressors early in our life. And I just wanted you to know that how the field has boomed. Epigenetics was being talked about in the 80s. I think I wrote a paper about in the late 80s, but it turns out that the number of publications, you'll just see the total publications in each year from 95 to 2010 has increased dramatically, just to show you how many scientists are now jumping on the bandwagon to help us understand this. And since 2010, it's gone up even a lot more. So now that you know a little about epigenetics, you can understand this figure. And this figure is about pregnancy, intrauterine stressors, maternal conditions, plus poor nutrition, high cortisol. That cortisol is the hormone that goes up when the mother's under chronic stress. And by the way, I just want to make sure you know, I'm not talking about stress that any pregnant woman faces on a day-to-day about missing an appointment or doing something else that they find stressful. That's not it. I'm talking about chronic stress that people suffer on the long term. Low oxygen in the womb, which I've mentioned, and toxic chemicals. Now, these stressors cause two changes. One on the left is they cause the organs in the body to be poorly made. And this is permanent. The number of cells I told you of your beta cells is determined early in your life. The number of filtering units in your kidney called nephrons are set before you're born, and you cannot make more after you're born. The number of cells in your heart are determined at the time of birth, and cells in the liver and the brain and wiring in the brain is also set. So there are structural changes that are made that are due to these stressors. On the other hand, there's something in addition to that, and that is the epigenetic changes. And these modifies the way genes get turned off and on. We think it's reversible. I'll talk to you about that later. And these two things, structural and epigenetic changes, lead to the risk for adult onset disease. And these can be passed on to future generations because epigenetics can follow the changes in genes that occur across generations. Now, I put this black arrow on the right because women who suffer all these conditions also have more risk for disease themselves, not only for their offspring. So I'm going to show you the growth pattern that can happen in a child. And this will be hard to explain for those of you who are not used to this type of graph. So I'm going to explain this to you. Across the bottom is age of years of people starting with 0 when they're born, all the way up to the age of 11 years old. And that dotted line in the middle is the average of the population where most people are. And you can see that as people grow, we could take the average and just call that the mean and call it a dotted line. So any line that's not on that average means that it's either higher or lower than the average. So if you look at the left, you'll see that the weight and height, that is green and blue, are lower than average in people who later had heart failure. And you can see that in the first years of their life, the first 4 years of their life, their weight and height got smaller and smaller compared to the average. Then at 4 years old, it jumped up dramatically between 4 and 5 and 6, and weight went up more than height. And that made the body mass index go up because body mass index is how much weight you have for your height. And it turns out that look what happened. It crossed the average line. And by the time that the people who got heart failure were at 9, 10, 11, they already weighed more than the average and their body mass index was much higher. Now this growth pattern also predicts type 2 diabetes, and we've seen it for other diseases as well. So the fact that the growth pattern of the child is based on what they weighed when they were born, and their risks depend on how they grew after that. But it's not all birth weight. There are other things that matter. The mother's phenotype, which is her height, weight, muscle mass, hormones, and things. The mother can predict, the mother's body can be somewhat predictive of disease in later life. The powerful one is the placenta. The size of the placenta, the way it's shaped, can predict these chronic diseases, and that means that mother stress are affecting the way that the placenta is made and whether or not that is likely to bring a difference in the offspring. Now, for many years, people left the fathers out of it, but that was a big mistake. Father effects are really profound and they're very important. We know less about them because they haven't been studied as much, but we do know that there are epigenetic changes in sperm. And these are associated with the father's diet, the stressors, and the phenotype. And so this is really important. And this is shown in a publication, and there are many more to go with it. So I just give you one example of how we know that a disease is related to the placenta. You can see here that all of these conditions, high blood pressure, low heart cells, heart defects, structural stiffness in the vessels, defects in coagulation system, coronary disease, valvular disease, sudden death, are all related and predicted by placental growth and function. And therefore, we know that the mother is interacting with the placenta, which is interacting with the baby as it grows, and has a powerful effect. And virtually all the diseases we see in cardiovascular medicine are also related to the placenta. Now I'm going to talk about maternal nutrition. Now this might not be a surprise to you, but the American Heart Association, through their surveys, compared people's eating habits around the country with the Healthy Eating Index. So if you eat a really healthy diet consistently, your score would be 100. And then when they averaged this across the United States, they found out that actually the average score is not anywhere near 100, it's 59. This is back in 2015 when they first did this. And now it turns out that they found that only 1% of the population is really eating a diet that's near 100, but about 72% of people eat poor diets and they are poorly nourished. And about a third, or 27%, eat a pretty good diet, but not consistently. And what they learned was that the entire population is in a nutrition deficit. And this includes people who are pregnant. So people who are pregnant live and work in the culture we live in, and therefore they're bound to be a part of the problem in terms of providing good nutrition for people. And this slide shows you that there are times in your life when you're more sensitive to nutrition than other times. So if you look at the height of the bars in the first 1,000 days, and the first 1,000 days after conception is about 0 time at conception through about 2 years of life. And you can see during that period of time that that people are very sensitive to nutrition for changing their epigenetics, way more than they are later in their life. And by the way, the calculation right now is that people live about 30,000 days. That's close to 80 years. That's their average lifetime. And the first 1,000 of those are really important in determining what kind of an epigenetic profile somebody will have for the rest of their life. And we call this developmental plasticity because it can bend. And what it means during that period of time, good nutrition can make a big difference and poor nutrition can make a big difference. Now, a lot of people haven't thought much about when a baby is growing in the womb, where does it get its nutrients? Well, obviously it gets them from the mother, but it's two sources. The mother's diet, all the fats and lipids, proteins and carbohydrates that the mother eats provide nutrients for her bloodstream that go to the placenta and transfer to the baby. But in addition to that, the mother's tissue stores of these compounds will turn over in pregnancy more than usual. So the lipid depots that a woman carries will release these free fatty acids that the placenta needs. The amino acids come from muscle, and they also are put into the bloodstream. And glucose comes from the liver, where it is stored as glycogen, and it's released into the bloodstream along with the nutrients that came from the mother. So both maternal tissue stores and maternal diet are important. Now, why do we bring this up? Because it's really important before pregnancy that a person who's going to bear a child will have good nutrition to improve the lipid stores and the muscle stores and the glucose stores that will eventually be changed and passed on to the baby. So I've talked to you already a little bit about transgenerational nutritional flow. And what this means is that nutrition, the effective nutrition, we call it nutritional flow, the effective nutrition goes from one generation to the next. So here we have a cute granddaughter on the left, and here's some things about her. Her mother's reproductive organs, including her ovary, were nourished in utero by her grandmother's diet. So that little baby there came from her mother, and her mother was once a fetus and was fed by her grandmother's diet, and especially her ovary where the eggs are made. Thus, poor nutrition by the grandmother will affect the reproductive organs of her mother, not only the ovary, but all her reproductive organs, and the epigenetic profile of the egg that made her. And lastly, the granddaughter may transmit disease risk to the next generation, her offspring. And I show you this by this little fountain there. Each one of those waterfalls is like a generation, and they just flow from one to the next. The health of the entire population is determined by the nutritional flow through mothers and fathers over 3 to 4 generations. So I'm giving you an example of an individual, but when you add up all the individuals in the country who are malnourished, that means that many of these effects are being passed on to the next generation. So I calculate this in egg years because I'm a really good example for that, and I'm going to explain it to you in a minute. But if you want to know how old you are in terms of egg years, that is how long ago the egg that made you was actually made, you can do it this way. So if your current age is 45 or whatever it is, you can add your mother's age to your age, and that'll be how long the egg has been in existence that made you. And so you have an egg that started you, and you have an age from the time that egg was made. Now, the reason I'm going to talk to you about this, and I'm the best example on earth, is because this we call the 100-year effect, not just because of me, but because I am an example of it. My mother died a year or so ago, and she was 99. And I'm in my 70s, and it turns out that the egg that made me was made in her almost exactly 100 years ago. So now the influences that might have been epigenetic from the formation of the egg can affect my health even 100 years later. There are some other effects that you might want to know about. And the one is the early embryo. And this work comes from Tom Fleming, a colleague of mine in Manchester. And what he showed was, if you look at this upper left figure, that's a figure of an oviduct, an ovary, and every month an ovary releases an egg. And if there's sperm in the oviduct, it gets fertilized and it makes an embryo. And that embryo moves its way down through the oviduct, and about a week later, it lands inside the mother's womb. And if all the conditions are right, it will start a pregnancy and grow a baby. But what's important about this finding from Fleming's group is they showed that these embryos that are traveling down the oviduct are actually sensing the nutrition level of the mother. And that means the amount of glucose and proteins, amino acids and fats, and they grow according to how much nutrient is available. So it turns out that you might figure this would be true. If nutrient levels are really low, the embryo makes more cells because it might want to make a bigger placenta so that it can nourish itself later. Unfortunately, what we do know now is the embryo looks like that little circle down in the middle, and the green cells will become the baby, but all the blue cells around the outside will become the placenta. And those change dramatically depending on the nutrition of the mother at the time the embryo is traveling down the oviduct. And the outcome is the heart structures are different, the kidneys are different, the blood vessels behave differently, and the lungs have different activities. And the outcome is an increase in cardiovascular disease risk and high blood pressure just from the 5 to 7 days of nutrition that are sensed by the embryo during that transit, all other things being normal. Tessa Roseboom, you'll see on the right-hand side here, has done the most to help us understand how poor nutrition in the womb can help us. She studied the Dutch hunger winter of 44 and 45 when the Nazis held Amsterdam or parts of it. And it turns out that calories were withheld, and many pregnant people there had about 700 calories a day for 5 months or more. And 20,000 people died due to starvation. And what Tessa found, and she's become really well known for these findings, is that it depends on the stage of gestation that the baby was in on how much risk they're going to have later in life. if the mother was in the early stages of pregnancy, just before the ban of food was lifted, then all of these different things on the list there, including cardiovascular disease and glucose intolerance, which is another word for diabetes, it turns out that these things all occur in the early embryo, if it was starved during that stage. But going all the way to the right-hand side, if the mother was only at the late stage of pregnancy, then the risk for glucose intolerance or diabetes is the only real thing that is occurring in those babies. So she found out that the time of the event of low nutrition really matters on how babies are getting developed. Now, a lot of people ask me, what is it that is important about the nutrition during pregnancy, or for anybody, anytime for that matter? And that is, there are foods that we should all eat all the time on a regular basis: whole grains, fruits and vegetables, nuts, legumes. And I don't want you to eat your goldfish, but remember to eat fish if you're not a vegetarian. And healthy oils, including olive oil. And this supplies many things: all the vitamins, minerals, saturated fats, antioxidants, and all kinds of hundreds of health promoting nutrients that we need. And all of these release their glucose slowly. Unfortunately, we have to avoid refined grains, and those include things like white bread. I'll just use an example. Foods that have a lot of added sugar and a lot of saturated fats, especially highly processed foods and meats. We call this ultra processing of food, and those are especially dangerous because they're pro-inflammatory. So my colleagues here at OHSU, and led by Christy Nays in the obstetrics department, she's a dietitian who developed this pregnancy plate with pictures. So people can see that when they eat, they can take from each quadrant some healthy food and eat a healthy diet day after day. Then lastly, I'm going to talk about maternal malnutrition and epigenetics, because this is really the part that is so new and to be honest with you, more difficult for people to understand. So I hope I can say it in a way that it'll make sense to you. First of all, epigenetics, I've already mentioned the basics of it. That is the modification of DNA to turn genes on or off. And we started realizing that this was important by studying identical twins. Now you can see these two twins on the upper left corner. They have different fingerprints, even though they're genetically identical. Why would that be true? That's because the swirls in fingerprints are laid down in the 13th to 15th week of gestation, and the amount of nutrition determines how many swirls you have. Now it turns out that twins inevitably are born with the same placenta. They share a placenta, but one gets more of it than the other. And the one who got more nutrition will have more swirls, and therefore their fingerprints will be different. And a colleague at the CDC showed a paper where even fingerprints can predict how much diabetes risk you have. The other point I'm going to make is that this has been shown really dramatically in mouse experiments. These two mice are genetically identical. The only difference is that their mothers had different diets. And the mouse on the left, which is yellow and fat, that mouse its mother had really poor nutrition and did not have enough of the nutrients needed to make epigenetic modifications that are important for becoming a healthy brown mice. So on the right-hand side, you can see that one of the ways in which genes are regulated is through the methylation of DNA. Now that might not mean much to you. Chemically, a methyl group is a carbon that has 3 hydrogens. And when it sticks to certain parts of the DNA, especially if there are a lot of them, the machinery for turning on the gene cannot get to the DNA, and therefore they turn the gene off. And that's a really important piece of understanding how genes are regulated. And I'm going to give you an example of how epigenetic methylation of a gene is actually harmful. Here's an example that's taken from my colleagues in Southampton. And what they studied was the methylation of the retinoic acid receptor. It won't mean anything to you or most people, but this receptor is important for regulating how much fat a person has. And it turns out that if you look at the black bars are showing how much fat mass a child has based on how much methylation this RXRA gene had. So now it turns out that this RXRA gene is important. We need it. But in some cases, the bars get higher and higher, and the fat mass goes up of a 9-year-old child because more of that gene has been methylated, and that's abnormal. And it's shown on the right-hand side too as a percentage of fat mass. Now, just let me make this clear. The more this gene is methylated, the more likely it is that that child will have excess fat by the time they're 9 years old. Now, the question is, what made these RXR molecules get methylated in those children? That's the really big question. And it turns out that in a study of all the dietary factors, they found one thing. And what they found was that their mothers are on a low-carb diet. And you may know of some low-carb diets that are popular and advertised all the time to help people lose weight. Those are dangerous for people who are pregnant because those tend to make this RXR gene highly methylated and make the child at risk for having obesity later in their life. So the two that I've talked about already that interact are one's called allostatic load, and that's the total load of all your stresses. And this toxic social stress you can see in that circle is chronic. It can be due to racism or housing shortages, physical abuse, safety fears, and poverty. All of these lead to high cortisol levels in the mother. Those go across the placenta and inhibit the growth of the baby. Babies are born small if they have high toxic social stress. On the right-hand side, harmful diets are the same. I've mentioned this already. Too much sugar, too much refined grain, excess saturated fats, harmful oils, and processed meats. All of these are part of a harmful diet that is pro-inflammatory and leads to epigenetic burden in the offspring, and that puts these people up to risk for having diseases when they're adults. So I'm not going to give you too much of a science lesson because I've already said it, but here are the ways that epigenetics work. Number one is methylation, and you can see there on the left that there's some little ME signs that are stuck to the DNA molecule. Those ME stand for methylation. And the more methylation there is, the more the gene is suppressed from being able to turn on. And that's why the RXR babies are having trouble, because they can't use that gene that is normally keeping them from getting fat. Then the second one is histone modification, and that is that DNA is wrapped around proteins in our chromosomes, and those DNA molecule, those histone molecules can be modified so that the DNA cannot be read between them, and that turns off genes too. And lastly, there are things called non-coding RNAs. These ribonucleic acids are made, they have their own genes, and they can also cause suppression of the products of genes being expressed. And now this is just going to be an example of how amazingly this has changed in the last 20 years. Here's a 2019 paper that shows all the epigenetic changes. Now, all those lists are genes. They're codes for genes that have been changed or epigenetically modified on the left in people who have obesity, and they can show it in different tissues in their body, different genes that are important. On the right-hand side, you can see the genes that have been modified by epigenetics in people who have diabetes. Now, we believe that most of the genes got modified very earlier in their life, but unfortunately, I've highlighted a few in yellow that we already know about, but unfortunately there haven't been enough studies yet to show how many of these gene changes that occur in obesity and diabetes actually started before birth. We don't know that yet. But the advantage of epigenetics over other genetic mutations is that this can be reversible, and I'm going to talk more about that later, and that gives us a hope for really changing the health of our population. So here's the way I depict it. See if you can get it. Here's a guy on the left. He's got a burden, and his burden is the genetic background that may make him have propensities for specific diseases. But there's even a bigger epigenetic burden that is changing the way those genes work based on his early life and all of the things I put in this list. So if you look on the lower left, grandparents, I've told you about grandmothers affecting their granddaughters. Grandparents can change epigenetics and add to the burden. Mother and father epigenetics, mother's toxic stress, mother's nutrition before and during pregnancy, nutrition during infancy, childhood nutrition and stress, the adverse child experiences which change the way genes work. And lastly is adult lifestyle. And by the way, adult lifestyle kills me because most organizations are now talking about how they can help adults be healthier. That's good. I'm in favor of all they're recommending. It turns out though, that they need to be prevented so that they won't get those diseases and they won't have a propensity for those. And that goes all the way back to the bottom of that arrow. So adult epigenetic burden is the propensity for cardiovascular disease, and it's carried by the epigenetic burden that people accumulate early in their life in particular, but all the way across the life course. Epigenetics also changes the way the clocks work on how genes work. I hope I can explain this the way that you understand it. When this paper was written, there are about 350 genes out of 20-some thousand, by the way, called clock genes, because these genes are sensitive to methylation to determine at the rate at which you're aging. Everybody is aging according to their aging clock, their clock gene, and we call that the epigenetic clock, because these clock genes can be changed by epigenetics and speed up or slow down the rate at which we age. So you can see in the blue figures, you can see this case is a woman who grew up as a child and then went through the normal aging process. And by the time she was 80, she was walking with a cane. And by the time she's 100, she probably will have already died. It turns out that if the epigenetic clock is sped up because of a lot more epigenetic changes in those clock genes, then the person ages faster. By the time a person is 40, you can see, or 38 in the case of the red in the second line, that woman has already aged a little faster than normal at the 40 in the line above. And sure enough, the 60-year-old woman looks like a 50-year-old person who has a sped up clock. And the woman at 60 down in the lower red is already acting like other people would at the age of 80 because her clock sped up and she has a high risk for heart disease, stroke, and cancers that will take her life, and she'll die before the age of 80. So this is happening, and there are many now people studying this. We're already studying the epigenetic clock in children, and there have been some really good studies that are showing that now we can see a little bit more about how that clock works very early in our life. Now, it turns out the American Heart Association has a lot of ways that they tell us to do better. And these include healthy diets, physical activity, and keeping our blood pressure under control, etc. We all know about these, but it turns out that almost all of these are determined your risk for these early in life. And so the take-home message of how this works is all these stressors that happen during pregnancy change the way the baby grows and elevates the risk for the mother having disease and the adverse outcomes of the babies And this is even higher for children who have adverse childhood experiences later. All of this adds to the epigenetic burden and is passed on to the next generation. So the question is, what can we do about this? So David Barker estimated that type 2 diabetes would be reduced by almost half in one generation. And by the way, let me tell you, it's only going up. It's never even gone flat, let alone gone down. But Barker suggested that if most babies were born at a normal birth weight and grew as children normally by having good diets and a healthy lifestyle, that heart disease and diabetes would both be reduced dramatically within a generation. And so I always have to show this slide because some people have said, well, you're just blaming mothers. The answer is no, we're not blaming mothers. What we're blaming is our culture. Our culture has a lot of nutritional stress, social stress, chemical toxins, and pregnant people are not at fault for the environment in which they live, including their diets, because they eat what all the rest of us eat. So it's really important to understand that in order to make reversal on this, we have to help this on a cultural level and not just on an individual level. So why is it so bad to eat bad food? Well, if you're looking at ultra processed foods now, and I've just read the book on it, that there's industrial food is adding a lot of chemicals, ultra processed food, and these are a sample of toxic environments that all of us eat every day. They're in our cereal, or they're in our bread, they're all the things that we buy on the shelf, except for fresh food. And plastic is in everything. All of these are really toxic chemicals. It's in our water, it's in our air, and people who are pregnant are exposed to those as well as those people who are not. So how are we going to do this? So we're in a very urgent situation with regard to the health of people in this country. And why are we not taking action? That's a really big question. But some of the excuses we've made is, well, it's all genetic. We can't do anything about it. That can't be right because it's changed so rapidly. We're not changing our genes that fast. It's normal aging, and the answer, no, it's not. We know from the epigenetic clock that people that age faster because their epigenetic environment is affecting the way they go through life. And people who smoke and drink and take drugs deserve it. That's what some people have said. You know, it doesn't matter if those are the people that are causing the trouble. They shouldn't do that. Now we understand a lot more about the social roots of these problems and why people are exposed to these drugs. And we look at it more from a disease point of view than just blaming people. What is the real reason? America's hooked on toxic industrial foods, and those foods benefit the American economy enormously. A state senator from Oregon explained that to me recently. Toxic chemicals are everywhere, food, water, and air, and many populations are highly stressed from poverty. So I said at the beginning that the health of Americans have been declining since the 60s, and that it was unlikely that the human race has ever faced this. But I also want to make the point that it's also highly unlikely that the epidemic of chronic disease can be reversed without a dramatic improvement in nutrition and stress among people who are having children. If we don't change it at that level, then we will continue to have an increasing risk because it's our hypothesis that these risks accumulate over generations. Here's the first slide I showed you, the take-home message. The health of the US population is deteriorating. The primary cause for chronic disease is stressors in early life, before birth and after birth. The early stressors that elevate risk include poor nutrition, social stress, chemical exposures, and poor oxygenation before birth. These stressors speed up the epigenetic clock in offspring and pass that risk on for multiple generations. This trend can be reversed by a healthy environment in the womb and in childhood because we are in trouble and we need to decide that we're going to fix this problem. So what can we do? If you're a practitioner, you can alert your patients as to the role of nutrition in transgenerational health. Everybody needs to know about that, even if they come in with a sore toe. Talk to your family about the importance of harmful stressors and future health. Families don't usually talk about this, but they need to. They need to know that healthy environments are really important for having healthy children and healthy grandchildren. Evaluate your own exposure to chemicals that cause harm. This is important. I do it for myself, and I'm starting to watch more about these toxins in food. If you need help, you should talk to a professional, and I'm really proud of these people that now I've come to know in the natural medicine field who know a lot of insight about how diet can help. And write your congressman or representative and join a group that is improving the environment. We need to get after this. And I'm going to remind you now that just in the last month or so, March 21st, I think it's going to be the third Thursday in March every year, is Natural Future Generations Day. And this is being kicked off by a group that really is sold on the fact that we have to turn our current trajectory around. That's the end of my talk. Thank you.
Thank you so much, Dr. Thornburg. It's a rallying cry. It's a clarion cry, I think, almost for us that are in the field of healthcare to really step up our game and help our patients for sure. I do have some questions for you. So let's start with this one. This is a good one. Are any of the epigenetic factors, nutritional, toxin, stress, more important than others? And if so, how?
I wish I could answer that with perfect clarity. We always thought that nutrition was the most important, and I suspect that that's still true. But we haven't been able to distinguish between diet and social stress in particular because of the epigenetic changes that are powerful from both of those. So there's going to be a lot more research before I can answer that question to anybody's satisfaction, including my own. We really want to study these independently so we know a lot more about how we can reverse them.
Wonderful, thank you. Yeah, more research is definitely warranted. Another question, I know my parents didn't eat well. What do I need to do to protect myself and my kids, and how much trouble am I in?
That is a really great question, and I get it all the time. And that's because almost all of us are derived from parents that didn't eat healthy diets. And what we have to do now is to make sure that our diets are mostly anti-inflammatory. You can look that up, but there are certain kinds of foods, of fruits and vegetables, and the ones I showed in this talk that actually reduce inflammation and reduce the effect of these epigenetic effects. And actually, in many genes, will take those methylations off of the DNA molecule so they can operate normally. So there's really good hope that we can reverse this if we could all eat healthy diets, exercise, and have low stress environments that are important for us to work out in our own personal lives.
Wonderful, thank you. Another question for you, how important is access to natural medicines and providers who specialize in whole health and nutrition if we're going to solve this crisis?
Well, the reason I'm on this talk is because I think it's very important. It turns out that most people in traditional medicine have not been well trained in nutrition, and therefore they're not very good at helping their patients evaluate their own condition and try to find ways to live healthier lives and have better nutrition for themselves. So I'm very pleased to be working with this group of the Institute of Natural Medicine to talk more about how people who have studied natural medicine could help reverse the tide that we're now seeing.
Thank you, and we appreciate your partnership in that for sure. One other question kind of related to that. If, as a practitioner, as a former practitioner, if you only had 5 minutes to communicate this idea with my patients, what do you suggest I lead with?
Well, that is a great question, and I thank you for asking it because it's a huge problem in medicine right now with so much pressure on practitioners to see a lot of patients. And my view is that if people come in with sore muscles, if people come in with a cough, if people come in with various kinds of complaints that they need to have addressed, no matter what their complaint, nutrition should be brought up for them. And they should be asked, do you eat a healthy diet? And if so, why do you think it's healthy? Because it's really important just to have the discussion. Even if you don't go and say, well, you better eat better before you come back and see me again, that's not going to help. What does help is having people understand that for all of their medical conditions, a healthy body will alleviate many of the issues that they face. And so I just hope that conventional medicine people, naturopathic physicians alike, are all really on board with talking to their patients about nutrition. We have to make this a standard.
Thank you. I totally agree with you. You're preaching to the choir here for sure. As a naturopathic physician, we have, I don't know, 140 some hours of clinical nutrition training in our education. It's really the foundation of what we do.
Yeah.
Health for sure. It would be great if all healthcare providers had an equivalent amount, or at least some amount of clinical nutrition training. Great. So how has this research in epigenetics changed your perspective on medicine and healthcare? Sounds like you kind of led into that a little bit, that last answer.
Well, I'm glad somebody asked that question, because I'm going to talk now for another hour. It turns out that when I was in graduate school, one of my professors actually told me that there wasn't anything new in nutrition to understand, because they'd already discovered the vitamins. And at that point in time, people didn't think nutrition was all that important. But I didn't add it to my list of expertise until I discovered that growth in the womb is dependent on nutrition in people before they're pregnant and during their pregnancy, and in the partners of people who are pregnant. Once I understood that, I became a nutrition expert, because it's absolutely crucial for understanding the origins of human disease and how they should be treated. I don't think all diseases can be treated by nutrition. I want to make that clear. On the other hand, healthy populations will avoid many of the common chronic disease conditions that we are faced with by having healthy diets throughout their life, and we better get there or our society is in big trouble.
Completely agree with you there. Again, I'm curious, the question is, what are some of the most common toxins and environmental effects that we see affecting these epigenetic factors in and around pregnancy?
Yeah, somebody mentioned recently in one of the scientific talks of my colleagues that they've now identified almost 1,000 toxins that people are exposed to in our society. And so nailing down the ones that are most important is not easy. First of all, we need to address all those that are legally added to our food. That's one big problem. And we don't know among those which are the most important, but the ones that have impressed me the most are the plasticizers. Plasticizers are chemicals that are added in making plastics to make the plastics work and turn into plastic. Those plasticizers are now being shown to be cancer causing. And even more important than cancer causing is that they modify the way our hormones work. And therefore, if plasticizers are in the blood of mothers, babies are exposed to them, their hormonal cycles are changed, the way their brain develops, and there's a whole host of things that go along with these plasticizers. And we are in a problem in this country because some states have banned BPA, bisphenol A, which is the most common one. And so they've just replaced those with other chemicals, but there haven't been good studies to see whether the replacements are also healthy and safe. We don't know. So BPA is banned, and many times you'll read on the label of food, BPA free. Well, I'm happy for that, but it turns out we need to know what about the other plasticizers that are in the plastic that we are exposed to all the time. So I'd go with BPA as the most important right now.
Yeah. It's interesting. I think in Europe they just banned the BPA chemicals, I believe, right? So maybe that's the trend that might reach here at some point. Who knows?
Yeah. And we just banned this last week, they banned red dye. And red dye
Right.
should have been banned a long, long time ago.
Exactly. Another question for you. How much of an effect does electromagnetic frequency have on cellular development?
That's a really good question, and it has not come to the forefront in the scientific community. You can look it up on the web and you'll find a lot of papers of people who have written about it. And what we know is that it at high levels will affect cells in a dish. What we don't know is what kind of exposures will make a difference for a human being. Some people have said you shouldn't use a cell phone because you get too much, and others have said it's so small that we should stop worrying about it. And I don't know the research well enough to have taken a side on this, but I do believe that we do need to be looking at it and look at it in a fair way to see what kind of effects. And I think it's very small compared to the toxins that we face every day.
Thank you. Another question, how does this apply to premature babies? Are they premature because of these factors?
Really great question. I'm sorry I didn't bring that up because small babies have issues even if they're born at term. But babies that are born prematurely have a list of added problems. Not only do they suffer the effects of epigenetic modifications, but they also have premature exposure to oxygen in the lung and other kinds of issues that affect their kidney and their heart. And therefore, they're at even higher risk than babies that are small, born at term. Many of these can be reversed. So I'm always talking about the negative, but I also want people to know that there's a lot of hope that we can help babies like that and other people that have been suffering under epigenetic modifications. And we need to think carefully about that so that we can take more action than we have been doing. We've been doing very little about reversing these problems.
Great, thank you. Another question, I got pregnancy diabetes in my last pregnancy. Is that from eating so much sugar or from family genetic events?
Well, I can't answer that question, but I do think it's a really good one. And that is that there are propensities for diabetes that come from our genetics. No doubt about that. Even if we don't have that predisposition from genetics, the epigenetics that happen on the way we grow during the womb, and as I showed you in our early life, and the way we put on weight when we're 4 years old, all of these can make a difference on our risk for diabetes at the time we're old enough to reproduce. So I think that I can't help you in identifying exactly what the issues. If you have a long family history of diabetes, it might suggest a genetic cause. But otherwise, it might be that there are propensities for diabetes that are strictly affected by epigenetics.
Got it. Great. If you could make one change to governmental policy related to this, what would it be and why?
Boy, being stuck with one, that's really tough.
Or a couple, yeah. What might be a couple?
Okay, well, first of all, the policies we need are to reduce inflammatory foods that we eat. That's the first thing we have to do. And those, I think, would be to outlaw the amounts of sugar that are put in processed food. Because people are taking in, we always try to say that adults should eat no more than about 30 or 35 grams of sugar a day. That might seem like a lot, but you can get that in one bowl of cereal. And you get 3 times that by drinking a certain soft drink. So it turns out that regulating sugar in the food would be the same equivalent of regulating tobacco. So I'd put that one number 1. And the other thing that in legislation that would help you is providing doulas for people who are pregnant who know about nutrition. That'd be the next thing that needs to be done, because people who are pregnant in general don't have any advice on any of these things we're talking about. They live their lives the way they live them, and nobody's there to help them eat healthier, to have a healthier baby, and have a healthier lifestyle. Those would be my two.
Beautiful. Thank you. Someone asked about the My Pregnancy Plate slide that you showed, the graphic. Is there a way
Yeah.
for folks to get that?
Yeah, it can be downloaded from the OHSU website. And if you Google My Pregnancy Plate OHSU, it'll come up and you can print it.
Wonderful.
Hey, by the way, I wanted to say something about that. That plate is really good for people who are pregnant, and that's the way it was designed. But that plate is good for anybody. I can tell you, I'm not pregnant, but I do think that it's valuable if you put that on the refrigerator, whether you're pregnant or not.
Good idea. Thank you. What is your perspective on resistance training during pregnancy to help modify the effects of poor or less optimal diet?
Well, moderate exercise during pregnancy is healthy all the way around, improves blood flow to the placenta, makes bigger babies, and it also helps the mother. So these are really important, not just strength. Strength training is helpful, but having other kinds of physical activity, I don't recommend, and I think most physicians would not recommend extreme amounts of exercise, running marathons and things like that, although people have done it. I just think moderate exercise is what makes people healthier.
Great. Let's see. Oh, is there anything we can do to counteract the influence of money and powerful business interests that are adding toxins to foods?
Well, I would like to have that as a point of discussion, because I really want to know the answer to that question. One thing is that, as I mentioned, you can join environmental groups, and I have some names and Michelle knows about these, of groups that are really working together to try to improve nutrition for people who are pregnant. That's the first thing we ought to be doing. But the money issue is another thing. We need to convince people not to buy food that's unhealthy. That's the most important way to do this, by banning all the things that are in food. That's going to be very difficult for us to do. And it would be fine if we could, but we're not going to do that in the near term. I think the important thing is to educate the public so they don't buy food that is not good for them.
That's great. I'll also say one thing, INM has a kids nutritional education program called Naturally Well, which we focus at fourth graders. And when you change a fourth grader's mind about something, it sort of plants a seed that grows throughout their life and can change their whole family's dynamics. We believe that changing kids' feelings about food and nutrition is an important strategy too.
Boy, I sure agree with you on that education front. That's really important.
Great. This is a wonderful question. This might be our last one, possibly. How has this research journey changed your life personally, and how have you grown since meeting David Barker?
David Barker and I met in 1988, and he showed his data for the first time, which showed that you have a high risk for heart disease if you're born at the low end of the birth weight scale, like I showed. And we had dinner that night, and just by chance, we sat next to each other. And he said, well, what do you think of my talk? And I said, well, I didn't agree with a word of it. and he said, what? And we had this long conversation. I said, the problem is there's no biological reason why it ought to be true. And until I'm a scientist, I want to know why it's true, not just if. And maybe that's a quirk in statistics. And we started having a good laugh about that. And eventually he said, well, why don't you join forces with me? And I did. And I had a really good time with him over his career. He moved to Portland and worked with me for a decade. And we published lots of papers showing how these early life events cause disease. It's changed my life. I look at food differently. I talk to my friends about it, and everybody knows that it's important to me to live a healthy lifestyle.
Yeah, you do live and breathe it, Kent. That I know about you, which is really great. And it is interesting when you think about every enzyme reaction, every biochemical reaction in the body, they are dependent on vitamins or minerals or nutrients, things that we get from our diet. So you just think about conceptually, obviously nutrition plays a huge role in our health. But it's really great to see the research coming forward so that we can get more people to really be interested about this, curious about it, and make some changes to policy. Yeah. Great. Okay, so I think that might be all the questions. Let me see. There was a question, will there be a replay of this webinar emailed out? And yes, you should get that email soon. And that, I think that will include it. So you should have all received a follow-up with just a 2 to 3 minute feedback survey. We'd love it if people would fill that survey out. Only take a couple minutes of your time. And we have that email that you get will have additional resources as well. We'll put that link into the My Pregnancy Plate that Kent mentioned as well. And I want to just thank you again for this inspirational kind of call to action message. I think it's a perfect time for this message to get out to the public and to our practitioners, have them learn more, share more with patients. It's a really important time for the community to know about patients and society, really. This is a way to achieve whole person health and hopefully start to bend that curve, that trajectory of chronic disease that we're seeing in our country that we're also concerned about. So thank you.
Thank you all.